Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 26 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, I want to give a shout out to our friends over at Sunfounder. Sunfounder is sponsoring this most excellent series of video lessons on the Raspberry Pi. And in this class, we will be using the most excellent Sunfounder Raphael Raspberry Pi kit. Guys, you know, this is a great kit. If you haven't picked your kit up yet, look down in the description. There is a link over to Amazon. You can hop on over there and get this most excellent hardware. And believe me, your life and my life are going to be a lot easier if we're working on identical hardware. But enough of this shameful advertising. Let's talk about what I am going to teach you today. And what we're going to do is we're going to learn how to use some of the components in our Raspberry Pi kit to build a temperature and humidity sensing device, a system where the results are printed out on the LCD display. Now, to make it a little bit more challenging, we said that you had, and basically this is the homework assignment solution, my solution to the homework assignment that I gave you in lesson number 25. And what you were supposed to do, remember, is you were supposed to build it with the DHT11 temperature and humidity sensor, and then display the results on the LCD. And then there was supposed to be a push button, and when you push the button, it is supposed to toggle between degree C and degree F, but not holding down and release that. It's now doing in Fahrenheit. You press and release. Now it's in centigrade. You press and release, and now it is back to Fahrenheit. So it is toggling back and forth based on a button push. How many of you guys were successful? If you were successful, leave a comment down below. I am legend. And if you were not successful, leave a comment. I folded up like a cheap Walmart lawn chair. Guys, don't feel bad if you fold up. It's better to try and not get it than it is to just not try at all. And if you really struggled and couldn't get it working, at least when you watch me, now you're going to learn, now I see what I was doing wrong. But if you just watch me without trying it yourself, then you think you understand it, but you really don't. Okay, enough of all this introductory chit-chat and banner. Let's jump in and let's see if we can get this thing put together. Hey, I haven't showed you guys my studio in a while. There I am. Okay. How do you like that? What I hate about that webcam is it won't focus beyond about 3 or 4 feet, so it doesn't give me a perfect focus on this, but you can get a little idea of what my studio is looking like these days. We're going to jump over here now to the overhead view, and let's look at what we are going to need in order to get this project done. You will need your Raspberry Pi, and then the Raspberry Pi is connected through the 40-pin ribbon cable over to the Sunfounder breakout board, and then we'll do the connections by connecting to this breakout board. Just makes life a little bit easier. You will need out of your kit the DHT11 temperature and humidity sensor. You should be familiar with that because we did that, 2 lessons ago. You'll need one of your push buttons. I chose red just because I could. And then you are going to need the LCD display out of the LCD1602 display out of the kit. And then you're going to need some female to male wires, 4 female to female wires, and then you're going to need some of these jumper wires. You know, I get the jumper wires from this Bojack kit. Just allows me to make the the build a little bit neater. But you guys should be familiar with that. Also, I just always sort of leave this board hooked up where I have jumper wires such that I power up the top rail and I power up the second to the bottom rail with plus 3.3 volts. And then I make this second row a ground by hooking it to the ground pin on this breakout board. And so basically when I need power, I can snag 3.3 volts or I can snag ground from either one of these rails. And you guys should sort of know what I'm talking about if you're this far along in the lessons. But we're going to have to jump in and we're going to have to get this thing wired up. We're going to have to get this thing hooked up, and then we'll go over and code it up. I got to tell you, and I got to remind you that to use this LCD display, you've got to go through and set up I2C, which I showed you how to do in lesson number 25. If you're following along in this class, you know exactly what I'm talking about. But if you're one of these drive-by shooters that are just jumping into this lesson, know that there's some libraries that have to be installed, and I show you how to do that in the previous lesson, lesson number 25. Okay, let's start by getting this thing hooked up. I'm going to turn it over, and I'm going to put the pins to the right. And when I put the pins to the right, I can see that ground is on the top. And so I'm going to get my female to male wires, and I'm going to hook ground. I'm going to hook a brown wire to ground. So brown is ground. And then VCC, I'm going to use the red wire because I like to use red for power. That's good. And then I'm going to go green is going to be the SCA. That's the next one. And then the SCL is going to be the blue. All right. So that is what we've got on the sensor side or on the display side. All right, those are hooked up. Now I'm going to come in to my power rail up here, my top row, and I'm going to put power. I almost accidentally hooked ground to power. Bad thing. But I'm going to hook my red wire to power. Okay, and then I am going to hook. No, I lied. This takes 5 volts, right? This display takes 5 volts, so I need to come down here to the bottom left. I'm just all mixed up. I'm going to come up now and I'm going to hook these things up. So I am going to hook power, the red wire, up here to the upper left, which is going to be 5 volts. Okay, and then I'm going to hook the brown wire to ground. And then you see this thing lit up and came to life. That's good. Now remember, the green wire is SDA, and you can read the SDA pin off of this breakout board, but the SDA pin is the second pin over is marked SDA, and then the third pin over is marked SDL. And so that should have that all hooked up very nicely. So this thing, you can see it's lit up, it's come to life. I have this hooked up. Okay, now what I'm going to need to do is I'm going to need to come in and I'm going to need to hook up the DHT11 sensor. And what I like to do is I think I'm going to hook this to pin, I'm going to hook this to pin 27. Okay, so I'm going to hook this to pin 27. All right, so I plug in 27 there. And then, did I hook that? Let me make sure so I keep this all consistent. I am going to hook it to pin 17, not 27. And so pin 17 is over here. So I'm hooking it to pin 17. And then what I like to do is I like to just come over to kind of like naturally how long the wire is so I don't have to bend it. And so that comes over to there. And then what you can see is I have this yellow wire hooked to 3.3 volts, this DHT11, it wants 3.3 volts. And then this wire I have coming to ground. And so if I look at these pins, left, middle, center, I have got plus, which is 3.3 volts. I have signal or out, which is the middle, and then the right one is going to be grounded. So I have 3.3 volts, I have signal or out, and then I have ground. So now if I just plug this in very carefully like that, I have my sensor hooked up. Okay, so we've got the sensor hooked up. We have the LCD hooked up. Man, we are running through this thing, but don't forget on the DHT11, it wants a pull-up resistor, and that pull-up resistor is 10K, and it goes between the center, the output, and the plus. And so we got a pull-up resistor there going from the center pin to the plus 3.3 volts. And so that's good. Man, we are really getting through this thing. Now we're going to come in and put our push button in. And so I will plug it in. Remember, when you plug in the push buttons, this pin is curved towards this pin. This pin is curved towards this pin, and that's what you put over the center trench, because the switching action comes between the two pins that are not pointed towards each other. The two pins that are pointed towards each other are already hooked together. So I'm going to have the ones, the pins pointing towards each other, those are going to jump across the trench. And then I'm going to come in here and I'm going to press that down. Although really, what I should do before that, again, I don't like to bend these wires, and this one I'm going to hook up. I'm going to hook the switch up to GPIO 21. So that wire is going to go into GPIO 21, and then GPIO 21 is going to come over here like this to its sort of natural extent, the natural extent of the length that it wants to be. And then I'm going to come over here, and the left leg is going to connect to that GPIO pin 21, right? Yeah, that's GPIO pin 21. And so that left leg of the switch is now hooked to GPIO 21. And you guys, this should make sense to you if you've been watching these lessons. Now, what do I need to do? I'm going to use the internal pull-up resistor. And so if I'm using the internal pull-up resistor, then the right leg of this guy needs to go to ground. And I didn't get that quite in there exactly. So we'll try it again. Okay. Now I have that left pin lined up properly with the, I still missed it, man. This is a little tricky one. Okay. Now I've got it. It's just, if I get over there, you won't be able to see what I'm doing. So now what I have is I have the GPIO pin 21, and I have it connected to the left leg of the push button. All right, now the right leg needs to go to ground, and so I will try to get this one the first time. Right leg to ground. Okay, right leg to ground, left leg to GPIO 21. Man, guys, I think in about 5 minutes with me fumbling around a little bit, I have this hooked together. Now, I'm not putting a schematic because I've shown you bit by bit in the last lessons the schematics of how to do this, and so I'm just trying to kind of review and get the things set up from the things that we have learned already. Okay, I think we are ready to come over and start trying to code this thing. And so what we will do is we are going to switch over. We are going to switch over to the Raspberry Pi view. And that got not quite straight. Let's get the universe in proper order by getting everything straight. Okay, now we're going to come over to our Raspberry Pi view. And so here we are, and what we're going to do is we're going to come down and we are going to open up our friend Thony, okay? And I remind you that in order for this to work, you have to have those libraries installed from the last lesson. Now what I'll do is I'll say a new program, and then what are we going to call this new program? Yeah, it's making me wait. Why are you making me wait? Let's try it again. File, new. Okay. All right, gave me a new one. All right, so it gave me a new one. Now I'll say save. And then what do we want to save this as? I think I'll say temp LCD like that. and .py. So we'll hit enter, and now we've got the program waiting for us to write it. All right, now we're going to have to do a lot of setup because we have how many components in this? We have 3 components. And so we've really got to be thinking, this is not hard. This uses the tools that you developed, the skills that you developed in the earlier lessons. Okay, so there's nothing really new here, but we got to really think through things, and we've got to kind of do it, be thinking about all the components as we develop it. So let's see if we can set these components up. If we're going to be using the LCD1602, we're going to have to what? We're going to have to import LCD1602. I showed you how to install that library last week. We're using GPIO pins, so we're going to have to import GPIO. We're going to have to import rpi.gpio as GPIO. Okay, now we're also going to be using the DHT11 temperature and humidity sensor, and so we'll say import DHT11. I also showed you how to install that library, and now we're going to need to import time. So we've got our libraries imported. We need to go ahead and set the mode of our numbering scheme for our pins, and so we're going to do GPIO.setMode, and the set mode is GPIO.BCM. Why BCM? Because on the Sunfounder breakout board, that is using the GPIO number, that's using the BCM numbering scheme, and so if I say BCM, then I can just read the labels off that breakout board, if that makes sense. Okay, so we have got that set up. That looks good. Now I need to create my DHT object. I've got to create my temperature humidity sensor object, and I'll just call it my DHT. And that is going to be equal to DHT11. That's the library that we just, that is going to be, my DHT is equal to DHT11 dot uppercase DHT11. And now I've got to tell it where it is. And where did we connect that to? Pin is equal to 17. So as I create my temperature humidity sensor object, I've got to tell the library where it is, and I tell it that it's at pin 17. And I glance down here, and yes, I have it connected to pin 17, so that looks good. So I've created my temperature humidity sensor object. Now I need to initialize the LCD display, so I'm going to say LCD1602, that's the library, and then init, I'm going to initialize it, and then what is the address? Where is it? It is on I2C27, and I showed you last week how to find the address of yours. And when we looked at it on mine, it was 27. If you don't know what I'm talking about, go back to last week's lesson and I show you what your address is. Yours is probably 0x27, but if not, you can go in and check it and put whatever your address is here. So that should make sense. Then a 1 here is going to turn the backlight on. So that should be good. Now we have a button, and so we're going to have to tell it what is our button pin, and our button pin was connected to GPIO 21. All right, now we've got to initialize that. So I'm going to say GPIO.setup. What are we setting up? The button pin. And then that is going to be a GPIO.in because I'm reading from it. And now what we have to do is, remember, I did not put a external pull-up resistor in the circuit, so we've got to turn on the pull-up resistor. So I'm going to say pull up down. Pull up down is going to be equal to GPIO.pull up down, PUD underscore, what is it? It's going to be an up. So now we should have all those components set up. Now we've got to initialize some variables. Remember, in the up state, the button is in a 1, and in the down state, the button is in a 0. but the first time through the loop it hasn't been read. So we're going to say the button state, we're just going to go ahead and set it equal to 1, meaning the button hasn't been pressed yet, and then button state old, it's not being pressed down now, and it hasn't ever been pressed down, and so we'll say the old state was 1 and the present state is 1. And now the temp mode. All right, what I told you that you had to do was to be able to toggle between degrees Fahrenheit and degrees centigrade. So when the thing fires up, it's in Fahrenheit. When you press and release the button, it goes to centigrade. And then when you press and release again, it goes back to Fahrenheit. So it toggles between the two states without you pressing, without you having to hold the button down. It's a toggle switch, not a press and hold switch. So we need to know what toggle state we're in, and I'm going to call that temp mode. And I'm going to set temp mode to 1. And conceptually in my mind, I want temp mode of 1 to be degree Fahrenheit and temp mode of 0 in order to be centigrade. Now, why didn't I put a mode of F and C? Because when I use 0 and 1, I can use Boolean operators, which is the not function, and that just makes it a lot easier to code. And so I've done this before, and you can go back and watch those earlier lessons if you need to review it. But temp mode equals 1. In my mind, I'm starting out in Fahrenheit. Does that make sense? I hope that makes sense. Okay, do we need to do anything else? No, I think that we are pretty good there. Now we need to put in our try and except so that we can cleanly leave, and then in here we'll have a while true just to create a loop in there. And then all of our code is going to be going in there. But so I don't forget, let's go ahead and do the except. And the except is going to be, keyboard interrupt, like that. And what do we want to do on keyboard interrupt? We want to clean everything up. And so what I'm going to first of all do is just put a little delay time sleep of time dot sleep like that, of about 0.2 seconds, so it gives everything time to finish. And then when you hit Control C, it'll come down here, it'll pause a second, and then it'll start cleaning things up, or I should say it's going to pause for a 0.2 of a second. Now I need to do a GPIO dot clean up like that, and then I'm going to clear the LCD, so I'll say LCD1602 dot clear to clear that up. And then I'm going to say print. I'm going to print system good to go. All right, so that means everything's been cleaned up. Why do I print that? Just so that I can see that it actually went down there and cleaned things up. Okay, now we got to come up and write the bulk of the program up here. So this will be up here in our while true loop. The first thing that we want to do is we want to read the button, okay? Because before you know what you're going to display or what you're going to do, you need to do your bookkeeping on the button. So I'm going to say the button state is equal to GPIO.input, and what am I going to read from? The button pin. So if it reads 1, that means the button is up. If it reads 0, that means the button is down. Now, don't forget your semicolon. Or that's a colon, right? That's actually a colon. Now, what do we want to do? Okay, we've read the button state. When do we want to toggle from Fahrenheit to centigrade? Well, if button state, what you just read, if that equal 1, which means the button is up, and if button state old equals 0, which means last time through it was pressed down and this time through it's up, that means you have released the button, and that means you want to toggle. So if the button state if button state is equal to 1 and button state old is equal to 0, then we want to toggle. And so in that case, toggling is temp mode is equal to not temp mode equals not temp mode. So what is that going to do? If it's a 0, it's going to become a 1. If it's a 1, it's going to become a 0. That's why I had the temp mode as a 1 or a 0, because I cannot a 0 or a 1. And that's a lot easier than trying to figure out how to deal. If you were keeping track of it with an F or a C, you couldn't use not. And so the not makes things a lot easier. Now what I'm going to do here is I'm now going to, let's print temp mode, just because that will help us debug if we need to debug, if we got a little bit of our logic wrong here. Now, what do I do? Well, now I'm done with the button. So when I am done with the button, then what happens? Button state old becomes button state. So I'm remembering what button state is for the next time through the loop. And if this doesn't make sense, go back and watch my lessons on toggle switches. But hopefully that will make sense. Okay, now I've taken care of my button. Now I need to go read the temperature and humidity. And so I do that by saying a result. I'm going to put it in a variable called result, and that is going to be my DHT, okay, my DHT dot read. Right, so now I've got that. Now temp C, it reports in temp C, but I'm going to go ahead and put in a variable. Temp C is equal to result dot temperature, like that. And now I want to convert to F. So temp F is equal to temp C times 1.8 plus 32. And you guys could look that up on the internet pretty easily. So I don't feel bad that I made you to convert C to F for this exercise. And then I'm just going to simplify it with humidity. Hum is equal to result dot humidity. Why am I doing this? Because when I get down into the nuts and bolts of the program, it's a lot easier if I can do temp C, temp F, and hum rather than have to deal with all this bookkeeping. So I'm kind of taking care of all the bookkeeping. Now, one thing that we know is that you can actually go try to do a reading and get a bad result back. So before you do anything else, you got to make sure that you got valid data from the sensor. We read it, but now what we want to say is if the result, which I just read, if the result dot is valid. So I only want to do this stuff if I got a good result. All right, now what do I do if the result is good? Then I need to see what mode am I in? Am I in Fahrenheit or am I in centigrade? So I need to say if temp mode is in Fahrenheit, well, that would be is it equal 1. I'm going to be in Fahrenheit. And in this case, I need to print things in Fahrenheit. So I would do an LCD1602 dot write, and then where do I write it? To column 0, row 0, and then I want to put the label temp. Okay, now you can't put a comma in the right, and so what are we going to have to do? We are going to have to build this thing sort of like one write statement at a time. So we're going to start by putting the label temp, and I think I'll put a colon and a space like that. All right, and that will write temp on the LCD. Now what I need to do is LCD1602.write, and I need to correct this up here. It doesn't want a dot there. Okay. Now what do I want to write now? Well, where am I going to write? I'm still going to be on row 0, but what column am I going to be on? Well, let's see. We got to count it. This is 1, 2, 3, 4, 5, 6. So I want the 7th place over, but since I'm starting to count from 0, the 7th place over would be what? The number 6, 0. The 7th place over is the number 6 when you start counting from 0. I hope that makes sense. And then what do we want to print? We want to print temp F. How many of you guys had a problem writing temp F? Well, temp F is a floating point number, and the LCD display wants a string, so we better convert temp F to string if we want it to work. All right, so now we have printed temp F, and now I need to go LCD1602.write, and now what am I going to write this time? I am going to write the label F on it for Fahrenheit, so I know where I am. Now, where do I need to put that? Well, I would go, I'll start counting with 0, and that way I won't have to subtract 1. This would be 0, 1, 2, 3, 4, 5, and then this would be 6, but you could have 100.0, so that would be 6, 7, 8. The period would be 9, and then 10. Okay, it would be the position 10 would be where you would want that. And that way you wouldn't, that's just in case you have a number over 100, you still have room for 100 and then 0.0. And so that would put it at the position, that would put it at the position 11 actually. Okay, and then what do I want to put here? I want to put the label space F. Okay, so let me see if I can do that again. This is 0, 1, 2, 3, 4, 5, and then 6, 7, 8, 9, and then 10 for the last 0. And then because I'm putting a space, or yeah, it would be 10 and then 11. Okay, and then it will just start with the space. You guys can draw a picture of this if you want to do it, or you can just kind of fool around with it to get things working. But I think I'm thinking through it clearly in my head. I'm not sure if I'm explaining it to you perfectly. Else, no, and that would be also on row 0. That's on row 0 like that. So all of these are on row 0, but we start at column 0, then column 6, and then column 11. Okay, now we will come down and say LCD 1602. LCD 1602.write. And then what am I going to write? This time I want to write humidity. Okay, and so where I'm going to go is I'm going to go back to column 0, and then I am going to be at row 1 this time, column 0, row 1, and then what am I going to print? The word humidity colon space, humidity colon space. Okay, then end the word and then end that print. Now I'm going to do LCD 1602.write. Okay, and I'm gonna stay on the row 1 because that's the second row down. But what place would it be? It would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for the space, and so it would be in the 10 spot, the 10 column, and then still the row 1. And now what do I want to print? The string of humidity. Hum is what we called it, I believe. Okay, and now the final write we're going to do is LCD 1602.write, And what are we going to write this time? Okay, well, you could imagine that you would have humidity and then the space, and then it could be like 23.4, 23.4. So it would be 4 more. And so we're going to go to 14, and then it would be 1. And then what I want to print, I want to print the percent sign like that. Does that look good? I hope so. That looks pretty good. Okay, now what I'm going to do is for temp mode equals 0, it's going to be almost the same thing as this. Okay, it's going to be almost the same thing as this. So I just cut and pasted, and I got a little goofed up there. I cut and pasted all that code that we just did, but this time instead of temp F, we want temp C, and then instead of an F here, we would want a C. And then everything else should be the same. Man, that went from being slow to being really fast all of a sudden. Is there anything else we need to do? No, I don't think so. How many of you guys are screaming at me for the tons of mistakes that I made in here? So I'm just going to kind of glance over this a little bit and see what's going on. Okay. It looks pretty good. There's probably some errors in here, so I will need everyone to hold their breath. Oh, syntax button pin. What is that? What is that in line 15 that it didn't like? Ah, that's right. You don't put a colon after a button state. Silly me. Who was it that didn't hold their breath? You know who you are. So this time I need you to hold your breath. Okay, so it's printing out button state. Let's just see if it is working here. Okay, I got a false. Man, I'm getting a kind of a strange result here, but let's see. I think I forgot something here. Let's see. I'm not sure why that's going. Okay, so you see it's toggling from true to false, which kind of looks like it sort of is trying to do the right thing. I'll tell you maybe what I should do up here. Maybe I should say temp mode is true like that. And I'll just start it out with true, because when I did the not, it changed it to true and false instead of 0 and 1. And then here I would say if temp mode is true. And then down here I would say if temp mode is false. Like that. Maybe that would be a better way of doing it. I do my conversions. I do my read. Button state old is equal to button state. I did that right. It seemed like it was toggling, but maybe I just needed to do true and false better. So let's see now. I thought 0 and 1 you could not, but apparently it's not very happy with that. So let's try it again. Okay, so this time it's going true, and then I click the button and it's going false, and then I click the button and it's going false. Let's try true. Okay, now it seems like the logic on the button is working, but now the real test is what's happening down on the bench top. What is happening with our hardware? And sort of to see what's happening on our hardware, we need to switch over to our hardware view. I need to get a little illumination on it. So we will come over here and we will come over to our hardware view and we will get everything perfectly straight again. Look at that. So what makes me happy? What makes me happy is I'm reading a temperature of 81.52. That seems right for where we are right now. It seems right for what it's feeling like in the room. Okay. And then 53 degrees, we live on the river, so that's probably right. And so now watch, I hold the button down, nothing happens. Shazam. Did you see that? Look at that. Let's do it again. Giddy up. Okay, 81.52 in F and 27.58 in C. All right, guys, this thing is working. And, you know, I didn't make that many mistakes in the coding. I'm surprised that I got through that without a bunch of typos. But I was sure that you could not a 0 or you could not a 1, but then it did, but it changed it from 0 and 1 to true and false, and then my if statements weren't working right, and so it got a little goofed up with that. Man, guys, this is really, really slick. Let's sit and just take it in. Let's take it in. Look at that. What if I hold the button down a long time? It's still working, and then let it up. It lets up on, we have the kind of trailing edge toggle switch. You could also change that if statement in there, and you could make it toggle on the button down instead of the button up. All right, guys, I think this went incredibly smoothly. I am really impressed with how smoothly this went. The lesson went well. You guys, give me feedback how this went for you. How many of you guys were able to figure it out? I am legend. How many of you guys had trouble? Folded up like a cheap lawn chair? And then I love it when you post your solutions to YouTube. When you do that, when you post your solutions to YouTube, in my comments below, leave a link over to your homework solution, and then on your video in the description, link back to this lesson, so people who come onto your lesson will kind of know what you're doing or know what you're talking about. And so this is really, really cool. Can you believe we've gone through 26 lessons already? I'll show you kind of what in my Sunfounder kit, what I am doing is I'm making these lessons. I'm coming in and then I'm marking off. I am marking off the components that we've done already. We've done resistors, we've done push buttons, we've done the LEDs, the RGB LEDs, we've done the ADC0834 A to D converter, we've done the joystick, the ultrasonic, we've done the DHT11, we've done the motion detector, we've done the servo, we've done the breadboard, the cables. Man, we are getting through this, and I am really eager to get through these components, because the more components you know, the more complicated and the more sophisticated projects that you're going to be able to build. And then I am just so eager to get to the camera, because I've got some just really, really exciting stuff to do the camera, and I'm really tempted. I really want to just jump in and do the camera, but I know that before we do the advanced stuff, we have to lay the foundation. You have to understand the GPIO pins. You have to understand how to analog write, how to digital write, how to analog read, how to digital read. And then you've got to learn how these different components work. And then boom, we start connecting them together and we start using multiple components. And that's when the magic really happens. So I'm really excited what I think we're going to be able to do when we get to the camera. Guys, I hope you're having as much fun taking these lessons as I am making them. If you're enjoying the lessons, give us a thumbs up. That helps us with the YouTube juice. Also, leave a comment down below. Subscribe to the channel. Ring the bell. When you do those things, then YouTube will show this video to more people. And that is important, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.